Hello everyone, this is Mr. 13 Things coming at you once again on a government-supported grant, if you would. And I'm coming to you today after spending a good portion of time sitting through some MIT courses as well as Khan Academy courses, concentrating on linear algebra. And of course, this is at the same time I am co-parenting and raising a couple of kids now in 10th grade and 7th grade, and am completely flabbergasted by how much more they could be, should be, and can be doing in their classrooms if and when people take note of what they're doing on their phones from the time they're in 3rd and 4th grade. As the father of daughters, the phone is a safety device. We can debate that later. Now, what I'm going to talk about today is basically off of Professor Strang's, Gilbert Strang, who is a genius, reminds me of Jimmy Stewart's site. But I'm going to remind you that this is then also layered on top of my pure belief that once kids get E, what E is, what I is, square root of -1, or I squared equals -1, EI pi, -1, 0, 1. Pythagorean's number, the square root of 2, the square root of 3, the square root of 5, the golden ratio, or phi, the concept of infinity, what a matrix is, and what a vector is, and how you work with them. They will be a long way along the route of figuring out exactly how their phones are working. This turns out to be, if you'll figure it out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 things, and hence you have it, the title, Mr. 13 Things. What I'm going to talk about today is basically from Professor Strang's class and from Sal Khan's linear algebra presentations, basically the two ways that we go about thinking about and multiplying a matrix by a vector. And of course, very often that you're going to see is going to turn out to be a vector, and we'll talk about what those things are. We'll also let you know that there are different formats for this. So already you've seen that I'm showing that a vector is just a matrix that's got a stack of just one number. And you will see this if you want to go out right now, believe it or not, and look for We Solve for X. We Solve for X.com. That's a www coming out of Google, and you'll realize that the X they're talking about looks like this. More on that later. All right, so the two ways we go about multiplying a matrix by a vector, or eventually a matrix by a matrix, is either thinking about rows or thinking about columns. And the earlier we free up the thought process to realize that kids and learners need to kind of start to see both ways, the better. For this reason, I'm going to just lay out right now and show the mechanics of multiplying a 3 by 3 by a 3 by 1 matrix by a vector. I'll just go ahead and do the 1, 2, 3, 4, 5, 6, and 7, 8, 9 here. And in this one, I'll go ahead and I guess I'm going to do 10, 20, and 30. So when you multiply these together, you will realize that this is a 3 by 3. Whoops, that wasn't good. And let's see if we can fix that here. There we go. A 3 by 3 by a 3 by 1 will get you a 3 by 1. So you know this is going to turn out something like this here. First and foremost, realistically, in the quote-unquote real world, you're just as likely to plug this into a calculator as you are any mathematical computation that you're going to do. However, it's important, just like it is with division or multiplication, to understand what's going on here. So we're going to start with perhaps the best way of thinking about this, And this is, at least according to Gilbert Strang, is the column way, and this being a linear combination of columns. So what this means is this is going to mean this is 10 times the first column plus 20 times the second column plus 30 times the third column. And I'll do that right now. I'm going to erase this out a little bit here. Think about it again, what the format looks like here, and it's easy to see when you're dealing with vectors. It's a little harder when you're dealing with a matrix times a matrix, but it is possible as well. It is a combination of columns. In other words, 10 times this column plus 20 times this column plus 30 times this column. And I'm going to draw some little arrows. I'll just try to do it in a different color. 10 times that column plus 20 times that column plus 30 times that column. That calculation gets you what, in effect, this turns out to be. Now I'll try to do this handy-dandy little grab that, and now we're back to our original color. So let's see if we can do that. Well, 10 times the first column would be 10, 20, and 30. Now, what you have to realize is that you have to know that then you're going to add the next column. The next column is going to be 80, 20 times 4, and 20 times 5, 100, and 20 times 6, which is 120. And then, of course, the last concept, or the last operation, is 30 times the last column, which is 210 plus 160 plus, I apologize for that, 270. Notice how important it is to put these pluses there and immediately solve by using your addition facts of this being 300 and this being 180, 280, and this one being, this one's going to be a little tough, 150 plus 270 would be 370 plus 50 is 420. And again, how do you get that? You get that by being a linear combination, 10 of this column plus 20 of this column plus 30 of this column. And that is, I think, for most people, the easiest and best way to start thinking about this calculation. Though in reality, when you're doing vector calculations, really what you're going to start thinking is about you're transforming this vector with this matrix. So that's why the mechanics become the easier mechanics do not necessarily describe what's really going on in a lot of, at least, first application of this. And the first application of this, you have to realize, is any computer graphics that exists on the planet. All right, so that's the first way. And this was, in fact, basically, according to Professor Strang, and there's no way I can compete with him, go out to MIT OpenCourseWare and figure out how quickly this is coming. This is the column thought. Now we're going to think about the row thought. We'll go through it again. Hopefully we'll fit this in, and we're going to do the same calculation and hopefully get the same answers. 1, 2, 3, 4, 5, 6, and 7, 8, 9 times the vector 10, 20, 30. This time the way you're thinking about it is this. See if I can do this. 1 times the first row plus 4 times the second row plus 7 times the third row. 1 times the first row, so we're doing it this way. 1 times the first row plus 4 times the second row plus 7 times the third row. Let's see if that checks out. That would be now 10 plus 80, and by golly, plus 7 times the last row plus 210. So it turns out the same way. Let's try the second one. 2 times the first row plus 5 times the second row plus 8 times the third row. By golly, that works out too. And finally, 3 times the last row. I'm sorry, 3 times the first row plus 6 times the second row plus 9 times the third row. And in fact, these then turn out to be the same. 300, 280, and 420. What's great about this in a classroom, theoretical or not, that classroom could be the 5-minute lift to school every day, is that one can break up what appears to be a complex multiplication into a set of steps that can be done concurrently by different rows, columns, groups of students in a couple of different ways, and they can learn about something called computational redundancy. If I make up a word, I apologize. The fact that students can practice some basic skills here and then also realize how important place value is far and beyond the ones, the tens, the hundreds, the tenths, the hundredths places. So I will keep this to hopefully around 15 minutes. So remember, now we talked about column thought and row thought. And now I'm going to take it one step further when it comes to row thought in terms of making a larger matrix. So how can we do this? I have no idea. I'm just going to actually go ahead and erase this out. And move on to the same concept, but just in terms of the row here, because this in fact is how most students, fortunately or unfortunately, learn how to do multiplication, because this is first introduced in school for systems of linear equations. Completely not in line with what kids are doing, which is playing 3D games from the time they're in around 4th grade. Systems of equations is where this is also put when you start looking at solving simultaneous equations. So we're going to try it this time differently. We're going to go ahead and do the 1, 2, 3, 4, 5, 6, the 7, 8, 9, and we'll keep that same. In this case, instead of 10, 20, 30, I'm going to go ahead and just do 2, 4, 6, and maybe I'll just do 2 here. 9, 10, and 11. And we're going to do now the row concept. And we're going to see how that, as you expand out to multiplying a matrix by a matrix, but a matrix can be thought of, if you think about it, as a series of vectors as well. How did we go about doing the row theory? Well, here's what it was. 1 times the first row plus 4 times the second row plus 7 times the third row. 1 times the first row would be 2 and 9, right? So we're going to do 2 and 9, 2 here, 9 there. 4 times the second row would be 16 and 40 plus 16 plus 40. And I'm going to go ahead and erase that out to give myself some more room here. We'll start over again, edit, cut. My theoretical hero, at least on the web, call him my 21st century man crush boyfriend, would be Sal Khan. And so we'll talk about the idea of an 18th century boyfriend or girlfriend in another video. All right, so here we're going to try this again. Remember, the concept is 1 of the first row plus 4 of the second row plus 7 of the third row. The 1 of the first row would be 1 times 2, which is 2, and 9 over here, plus 4 of the second row. 4 of 4 is 16 and 40 plus 16 plus 40 plus 7 of the third row, which is plus 42 and plus 77. So we have, in fact, our first place right here. We'll do it now, again, the row method. 2 of the second row. 2 of the first row is 4 and 18. 5 of the second row, which is 20 and 50. And 8 of the third row, which is 48, there goes my math facts, and 88. I'm beyond the 15 minutes, I'm up to 20. We'll live with it. You don't want to generally do this, however. You got to cut it up into smaller pieces, which adds extra work for anyone who is going to start to try to attempt this. Finally, 3 times the first row is 6, or 27. Plus 6 times the second row, plus 24, plus 60, plus 9 times the third row, which is 54, and 9 times there is 99. Now, I will leave it to you to calculate this. I'm going to end this video by bringing up right now a tool that everyone has access to, should they care to take advantage of it. And we'll see if we can bring it right up on top of the video here. And that is a TI-83 emulator calculator. There it is. Kind of move this stuff around, and we're going to try to see if the calculator can do this just as well for us here. So I'm going to try to move this around. Probably getting a little weird for you. There it is. So let's see how we can do this. I may have to move it back. Let's see, that's going to almost give me space. Well, we're going to walk over the 3 here. You're going to live with that. Completely available at TI. This is a 3, and we're going to go ahead and turn this on. Clear. Just like you would probably not do long division by hand after you get through with those exams, you wouldn't do matrix multiplication by hand. This has so many uses, and it's used so often by kids starting in around 4th grade on their phones or on their games or wherever. You don't want to ignore it till a college classroom. Lots of ways to do it. The calculator here is a little bit iffy to start, but it's not too bad. We're going to go to second matrix, and we're going to go and edit matrix A. We're going to make matrix A 3 by 3, and we're going to give the numbers 1, 2, 3, 4, 5, 6, not correct. That's going to be 3 times 3, 6, and then 7, 8, 9. So you have now 1, 2, 3, 4, 5, 6, 7, 8, 9, just as we did here. And we're going to hit second quit, knowing that is stored. Well, now we're going to make the vector, second matrix. We're going to put the vector in matrix B. We're going to make that not correct, second quit. Second matrix, you start to realize we're going to edit matrix B. Matrix B is going to be 3 by 2. And those values we said were 2, 4, 6, 9, 10, 11. Second quit, second matrix A times second matrix B. And just to be smart about it, we're going to store it in second matrix C. You'll see at this point, I don't know which one I trust. This one is not correct as I did it on the calculator or by hand. And this one, let's say they're different. And how are they different? Well, if we look at this one is right. My calculation error is probably wrong here, so I'm going to check that one. 1 times the first row, which is 2 and 7, 2 and 9. 4 times the second row, which is 16 and 40. And 7 times the third row, which is 42 and 77, which is just my bad handwriting. 42, 16, and 2. We're still a little off here. I'm going to end the video, look for the error, and post it on top of this one. But remember, for review, the idea of the column method or the row method, and then also the idea that computations are done via calculators as well. Thanks for listening.